So in today's lecture we're going to talk about two functional group. One is carboxylic acid and second one is an ester. So let's start with the carboxylic acid. So how does the functional group of carboxylic acid looks like? So we already talked about the carbonyl group, and in carbonyl group if one of the bond on the carbonyl group is replaced by OH, then this entire group we call as carboxylic acid. So basically, if you have a carbonyl group and in one of the bond of the carbonyl group you attach hydroxyl group, OH group, then this entire group we call as carboxylic acid group. So sometime you will see the carboxylic acid group looks like this way, and sometimes they can be abbreviated like COOH, or sometimes you can see CO2OH. So all these three abbreviations are same. So if you see any of these abbreviation, that means you're talking about carboxylic acid. So carboxylic acid compounds are normally found abundantly in nature. For example, lactic acid is present in our body while we do more rigorous exercise. Our body muscles normally filled with lactic acid, and some lemons or citrus fruit contain citric acid. So there are many other carboxylic acid containing compounds that can be found in nature. So there are a couple of examples of carboxylic acid containing compound. For example, acetic acid, which the name is ethanoic acid, that we're going to learn how to name the carboxylic acid containing compound. But just right now remember, acetic acid it can be used an active ingredient in vinegar and is used in food preservation, right? So you have many other carboxylic acid that can be used in different ways, right? And you have some structural formula of their structure. So now let's try to learn how to name any carboxylic acid containing compound. So the rule will be the same, but the only difference is you have to give the priority to the carboxylic acid carbon. So this is a carboxylic acid group, functional group, and the carbon that is present in the carboxylic acid, you have to give the priority or to give the lowest number to this carbon. So in this particular example, over here, you have to give the priority to the carbon of the carboxylic acid, and then you have to go left 1 2 3, and you have 3, that means propane. 3 carbon containing organic compound is propane, and the ending word of any organic compound that has the carboxylic acid, it should always be end with oic acid. So that means you have propane, oic, and then at the end you have to write acid. So always remember you have to end the name of the organic compound with oic, and then at the end you have to write acid, right? So in this case, propanoic acid. For example, one more example let me give you. So this is one of the example. Over here, this is your carboxylic acid group. The time I see carbonyl group with OH group attached to it, we know this is a carboxylic acid group. So we have to assign a lowest priority to this carbon that the carboxylic acid carbon. So this is 1, this is 2, this is 3, this is 4. So 4 carbon compound is butane. But because this is a carboxylic acid, we have to end our word with oic acid, butanoic, and then at the end write acid. So the name will be butanoic acid, or you can write 1 butanoic acid. So it doesn't matter, because if any functional group is present on the first carbon, we usually don't write the location of that functional group. But if you want, you can write 1 butanoic acid. Similarly, like for aliphatic hydrocarbons containing carboxylic acid, similarly for benzene ring, if a benzene ring contain a carboxylic acid, we have a special name. So what's the name? If you have a benzene, this is benzene, and on benzene if you have a carboxylic acid, the name of that particular compound or this entire compound is benzoic acid. So benz comes from the benzene, oic because you have the carboxylic acid on the top of benzene, and then this you have an acid, so benzoic acid. So the time you see benzene with carboxylic acid, you know the name is benzoic acid. Right. So let's take this example that is given on the PowerPoint. So the time I see you have benzene with a carboxylic acid, I know this is what? This is benzoic acid. This is our main parent chain. Right, that's already written over here. Aromatic acid name are derived from the parent compound benzoic acid. And then you have to name the carbon that contain the main functional group, in this case carboxylic acid group. So you have to give the priority to that carbon on the benzene ring that has the carboxylic acid group attached. So this is 1, this is 2, 3, 4. So these are the substituent. This is also substituent. So the name will be 3, 4. You have the same substituent twice on the benzene ring or benzoic acid, that means di. You have methyl group. What's the name of the substituent? Methyl. This is also methyl. So 3, 4 dimethyl, and then the parent chain is benzoic acid, like I already told you. So the name will be 3, 4 dimethyl benzoic acid. Right. So let's try to name a couple of more carboxylic acid containing organic compound. So let's start with the first one over here. So the time I see this group, we know this is carboxylic acid group. You have to give the priority to the carbon of the carboxylic acid, and then 2, 3 is propane, and because this is acid, propanoic acid. Right. So let's do the second one. Again, give the priority to the carboxylic acid carbon, then 2, then 3, then 4. So I can write 3 bromo, and then we have 4 carbon altogether, so 4 is butane, but because this is carboxylic acid, butanoic acid. So this is the name of this organic compound that contains the carboxylic acid, 3 bromo butanoic acid. Okay, so the solution is also provided on the PowerPoint, so you can read it along, but I already showed you how to name the compound that has the carboxylic acid, and we already solved both of the example on the previous slide. So let's solve a couple of more examples. How to name the carboxylic acid compound. So if I have this molecule, okay, then we have second, then we have third, okay. So let's try to solve all these 3 problems, or try to name the IUPAC name of all these 3 organic compounds that has the carboxylic acid group. So let's start with that first problem. The time I see we have this group C double bond OH, we know this is carboxylic acid group. So let me write it again. Okay. So we have to give the priority to the carbon that has the carboxylic acid group. Then this is second. Now I have to go to the left side because I have got two more carbon rather than going to the right side which has just one. So we have to go to the left on this particular example. And then this is act as a substituent. Right. So how are we going to name this molecule? We can write 2-methyl, and then we have 4 carbon altogether. I can write butane and then oic, then acid, butanoic acid. Right. This is the name of the first molecule. Let's go with the second one. So the time I see the molecule which is given over here, I know this is benzene, and we have carboxylic acid group on the top. We know this is what? This is benzoic acid. And then because this is benzoic acid, we have to give the priority to the carbon that contain the acid, carboxylic acid. So this is one. Now we have to see whether we have to go clockwise or counterclockwise. So in this particular case, we have to go counterclockwise. That means from left to right. So we have to give 1, 2, 3, because the lowest number on the carbon that has a substituent is 3. If I would have gone to the right clockwise, the first substituent is gonna be coming on the 4th carbon, so which is not the right way of doing the numbering. So that's why we are going counterclockwise over here. So 1, 2, 3, 4, 5, 6. So I can write 3, 4 because we have two same group, dibromo, then benzoic acid. Okay, let's try the third one. This is a little bit different. So over here we have two functional group, two carboxylic acid group, if you can see, within the same molecule, right? So we're going to see how we can name this according to the IUPAC nomenclature. Okay, so now you can give the priority to the carbon of the carboxylic acid, but in this particular case you have two carboxylic acid, so you can give the priority to this carbon first and then keep on numbering like this, 1, 2, 3, 4, or you can go vice versa. You can go left to right, or you can write this carbon as 1, then 2, then 3, then 4. So in this particular molecule it doesn't matter because both the functional group is appearing on the first as well as on the 4th carbon. So in this particular case it doesn't matter which end you're going to start the counting. So let's go from left to right. In this particular case, that means the black color pen marking is our way of counting. So I can write how many carbon we have in total, 4. So I can write butane, and then on the first as well as on the 4th we have carboxylic acid group. So I can write 1, 4. How many group you have? 2, dioic acid, because we have 2 times of carboxylic acid. That means we have dioic acid, right? Or you can also write 1, 4. Butane dioic acid. This is also right. So you are specifying on the first carbon as well as on the 4th carbon you have the carboxylic acid within the same molecule. So this is the name that you can use. So now let's talk about the physical property of the carboxylic acid. So carboxylic acids with low molecular weight are liquid at room temperature as well as have characteristically sharp and unpleasant odor. So we're going to talk about why carboxylic acid are liquid at room temperature, the low molecular weight, right? So we have to see the structure of the carboxylic acid. So if we remember, carboxylic acid is COOH, right? and this R group is any alkyl group. That means carbon containing compound, right? CH3s or CH3CH2. So we are just focusing on this particular group. Carboxylic group is in this particular example. So we can write carboxylic acid the way it is over here. You have, let's see the picture over here. We have C double bond O, then we have C double bond O, then we have OH. So this is one carboxylic acid group. And if you have another molecule side by side, then you have one more carboxylic acid group from the second molecule. So this is molecule 1, this is molecule 2. Right, and we can write the carboxylic acid the way it is, shown in the PowerPoint slide. So now we have to see, is there any hydrogen bonding that these carboxylic acid can make with themselves or with a different molecule? So let's see over here. So you have the carbonyl group, and then if you remember, this oxygen is electronegative, and this oxygen has the hydrogen group attached to it in the carboxylic, right? If we have the same molecule again, we have carbonyl group over here too, and then we have oxygen attached to the hydrogen. So if you remember, I told you if oxygen is attached to the hydrogen, fluorine attached to the hydrogen, or nitrogen attached to the hydrogen, they can show hydrogen bonding if you have another electronegative atom side by side. So they can show hydrogen bonding. Right, so we have to see in the same structure if we have anything like this over here or not. So the time I see we have oxygen attached to the hydrogen, and this hydrogen is close to the electronegative atom, oxygen from the another carbonyl group from the another molecule, so they can show hydrogen bonding. Hydrogen bonding, right? Similarly, from the first molecule, this oxygen have hydrogen attached to it, and this hydrogen is close to the carbonyl group from the second molecule, so they can show hydrogen bonding. Right. So what's the special characteristic you can see for the hydrogen bonding in carboxylic acid? So within the same molecule, or if you have two carboxylic acid molecules side by side, they can form two hydrogen bonding. Right, so each molecule of the carboxylic acid can form two hydrogen bonding with another molecule of the carboxylic acid. Right, and because within the same molecule you have two hydrogen bonding, that means they are held tightly or strongly together, so that's why they have highest boiling point. So remember this thing, boiling point, because of presence of two hydrogen bonding within the same molecule. If you have multiple hydrogen bonding, that means you have stronger attraction between the molecule, and if you have stronger attraction, you need more energy to break that bond, right? So that's why the boiling point is higher. You need to provide more energy. So the formation of intermolecular hydrogen bond cause high boiling point, which is greater than alcohol. So why the boiling point of carboxylic acid is greater than alcohol? So we are talking about boiling point. So in the previous slide we learned about that carboxylic acid has a higher boiling point compared to the comparable alcohol molecule. Right? So these are the sequence, or we are just comparing the boiling point of different hydrocarbons or the functional group. The first one is alkanes, ether, aldehyde, alcohol, and carboxylic acid. And you have almost the same number of carbon in all of them. So we are comparing side by side. So if you see the boiling point, you will see carboxylic acid has the highest boiling point. Right, and the boiling point is keep on decreasing if you go from carboxylic acid to alkane. So that means the sequence of the boiling point is carboxylic acid has the highest boiling point, then you have an alcohol, then you have aldehyde, or you can say ketone, then you have ether, and at the last you have alkane. Right, so this is a sequence of boiling points. So carboxylic acid has the highest boiling point, and then alkane has the lowest boiling point because you don't have any hydrogen bonding in an alkane. So make sure you know this information. So if I ask you anything regarding the boiling point, you know this concept, which one has the highest boiling point compared with the another one. Okay, so now we talk about what's the solubility of carboxylic acid compound in water. Right, so if you dissolve any carboxylic acid compound in water, whether they are going to dissolve or not. So like we see, this is a carboxylic acid group, and then this is water. Right, so one of the carbonyl group of the carboxylic acid going to form a hydrogen bond with the hydrogen of the water. Right, similarly, the second one over here, hydrogen bond, in this case the hydrogen of the carboxylic acid that is attached to the oxygen is going to bond with the oxygen of the water molecule. Right, and R is normally the length of hydrophobic carbon chain. If this chain is larger, then the solubility of the carboxylic acid organic compound is gonna be lower. So as long as this R group is normally contain 4 to 5 carbon, carboxylic acid compounds are soluble in water. But as long as after it crosses 6 or 7 carbon, or the length of the hydrophobic carbon chain is gonna increase too much, then the solubility of the carboxylic acid compound is going to decrease. Right? So make sure you know this thing. The length of the hydrophobic R group should not be large. The carboxylic acid are water soluble. So now let's talk about couple of reactions that carboxylic acid shows. The first one is carboxylic, the acidic property of the carboxylic acid. So let's talk about the acidic property or acidic characteristic. Okay, so the name is already telling you this is a carboxylic and this is acid. So that means carboxylic acid showing or normally show the acidic property or acidic reaction. So let's take an example. So carboxylic acid behave as a weak acid. So it's not a strong acid, and it forms carboxylate ion in water. So we'll see how does this reaction work or goes. So this is a carboxylic acid, and if you dissolve carboxylic acid in water, you're gonna get depending on the pH. So we'll see how this pH affects the reaction. You're gonna make carboxylic ion and hydronium ion. This is hydronium ion S3O plus. So how does it work? The hydrogen, because of this hydrogen, carboxylic acid are acidic. Because the time you remove this hydrogen is gonna go to water and form S3O plus. Right, because this hydronium ion has one more hydrogen compared to the water molecule, so that's why they are adding, they have a positive sign. And so if you know from the definition, acids are those compounds that can donate a hydrogen molecule or provide the hydrogen or proton ion. Right? And then you have the carboxylate ion. So let's see about how these conditions affect the reaction. If you can see, this is a back and forth arrow. So arrow, and then this is an arrow. So if this reaction is happening in high pH, what does it mean by high pH? Means you have less H plus sign in the solution. So that means this carboxylic acid can provide the H plus ion to the solution because the solution is basic. So this acid can provide hydrogen ion and convert into a carboxylate ion. Whereas if the conditions are acidic, that means pH is low, means you have high concentration of H plus ion already present in the solution where the reaction is going on. So that means the H plus is going to attach with this negative ion, O negative, and then the reaction go backward to its carboxylic acid and water. So depending on the condition where the reaction is going on, whether it's basic and acidic condition, you can easily predict the product. Right? So let's take an example. Over here, this is acetic acid. This is a common name. But if we have to write the scientific IUPAC name, what should be the name? This is 1, this is 2. 2 is ethane, this is ethanoic acid. Right, so if this ethanoic acid react with water, what's going to happen? This hydrogen is given by the acetic acid or ethanoic acid and is going to go with water. So in this particular case, water is acting as a base. Similarly, right, and this is act as an acid. So we know what is base. Base is that compound that normally take up the hydrogen, right? And acids are those molecular compounds that give the proton, right? Okay, then you're gonna form acetate ion from acetic acid to acetate ion and then hydronium ion. Right. So this is how the carboxylic acid shows acidic property. Right. So this is a weak acid, like I told you. Why? Because you have an equilibrium sign, something like this. So this equilibrium sign means the reaction the acids are not strong acid and it's not converting everything to a carboxylate ion. They're going back and forth. Right. Okay. Similarly, carboxylic acid also react with a base, with a strong base, and gives out or form a salt molecule, right? So let's see how does it react with a base. This is carboxylic acid group, this is a base, and what's going to happen if acid react with a base? You're going to get neutralization reaction. So if you have an acid, if you react with a base, you always get salt plus water, and we call this as neutralization reaction. Because you are neutralizing acid and base together, right? So what's gonna happen over here? This hydrogen is going to attach with this OH because hydroxide ion is a base. Because of sodium hydroxide, this OH negative is gonna take H plus ion and they're gonna form water. So H plus OH, water. So what's going to happen if you remove this hydrogen, this oxygen will get a negative charge, and then we know sodium is a group 1 element, it always forms positive 1 charge. So negative and positive come close together and form O negative and A plus, right? And this is we call as salt. And how we name as any salt? You always write the metal name first, sodium. Always write the metal name first, and then the name of the acid, carboxylic. But this is not an acid, that's why I'm not writing carboxylic acid. We are going to write carboxyl, and the name of the salt, remember this thing, always end with 8, right? So carboxylate. So metal name is what? Sodium, and then the rest of the part is carboxylate, right? So make sure you know how to name any salt. So the metal name plus the ending word of the salt always end with AT, right? Okay, and then the base can be NaOH, KOH, right? Any strong bases. The reaction will be same. So let's take a couple of more examples of carboxylic acid react with a base. In this case, we are going to use acetic acid, which is also a ethanoic acid. Then this H and this OH is gonna come close together, form an water molecule, and then this will become negative charge. Sodium is a positive charge because this is a metal, group 1 metal, always form positive charge cation, and then they come close together to form O negative and Na plus because of the ionic interaction, and this is a salt. So the name will be sodium because you have a metal sodium first, and then this is a common name acetate because we are starting with common name acetic acid. That's why the name is sodium acetate. But if we were using the iopic name, which is ethanoic acid, the name will be sodium ethane OH ATE, right? The name of the salt always end with ATE, right? Sodium ethanoate. So this is the iopic name, and this is a common name, right? So let's take one more example. We know this is benzoic acid react with potassium hydroxide. This and this OH is going to combine together and form water, and then this K is also is a metal because, and then this is a positive charge, and this is gonna be negative charge after it lost its proton. They're gonna come close together because of ionic interaction, and they form potassium benzoate. If you know how to name it, metal name first, then the parent chain, which should be benzoic, but because this is a salt, we are going to write benzo and then ATE at the end, sodium potassium benzoate, right? So that's why the name of this product of this salt is potassium benzoate, right? Okay, so I already explained you what are carboxylic acid salt, how to name it. Then you can read it along the PowerPoint, but you should be able to name this molecule that is given in the PowerPoint right now, because this is sodium, metal name first. This should have been a benzoic acid, but this is a salt. That's why benzo and AT at the end, sodium benzoate, right? And then most of the salts are solid at room temperature, and because if you are making a salt, they are always soluble in water because they are ionic in nature. They are ionic compound. If you can see over here, they are ionic compound, right? So they are soluble because water is also polar. If this is polar mix polar molecule, right? The main important thing of making a salt is even a longer chain acid can be solubilized by converting them into a salt. Let's take this example over here. How many carbon you have in this carboxylic acid together? 16 plus 3, 19, and 20 carbon chain. So is it possible to dissolve this carboxylic acid in water? No, because we already know only 5 to 6 or maximum 7 carbon containing carboxylic acid can be dissolved in water because of the hydrogen bond. If the number of carbon is greater than 7, then it is going to be hard or difficult to dissolve that carboxylic acid compound. But if we react this high carbon containing carboxylic acid compound with any base, they're going to form a salt, right? Sodium, the name is stearic acid, in this case stearate, right? And if you can see over here, without a salt, this entire molecule is insoluble. But once you make the salt, once you react it with base, you're making it soluble, even though you have the same number of carbons, 20 carbon. So that's the importance of making an any acid salt or any salt, because they can help you to solubilize even the higher number of carbon. Okay, so now let's talk about another functional group called ester. Ester functional group is a key structural feature in fat, oil and other lipid. That means you can find the same functional group in fat, but when we're going to talk about lipid, you will see the same functional group is present in lipid, which is a type of, which we can have fat, oil and another type of lipids. They are also found in fruit and flower because they are give fragrance, and it represents some of the nature most pleasant odor. And this ester containing compound also used as a flavoring agent in food as well as in some scent for a personal product. So now let's talk about how does this functional group. So ester has a functional group. We have a carbonyl group. This is a carbonyl group. If one of the bond of the carbonyl group contain R and another bond is replaced by O R, so this functional group is an ester, right? And then this bond between carbonyl and oxygen we call as an ester linkage or as an ester bond, right? So the time you will see carbonyl group attached with one more oxygen, and that oxygen attached to then any alkyl group, either CH3, CH2, or depending on how many number of carbon you can have, this is an ester linkage or ester functional group. So how are we going to form this ester compound? So they normally form when carboxylic acid are heated with alcohol or phenol. So remember this thing, whenever a carboxylic acid react with an alcohol or phenol, they form an ester compound, right? So let's take an example over here. This is a carboxylic acid and you have an alcohol over here, ROH, and in the presence of an acid catalyst and in the presence of heat and acid, H plus means acid, right? They form carboxylic and ester. So we'll see how this reaction goes. So this is carboxylic acid. The OH from the carboxylic acid and hydrogen from the alcohol get removed from the molecules and converted into water, and then the rest of the remaining molecule from carboxylic acid part and alcoholic part combine together. So what else is left? You're left with RC double bond O, which is this R C double bond O, and then OR, then you have OR. So this is we call as an ester group, right? C double bond O, O, carbonyl with oxygen. And then what is an ester linkage? You have carbonyl group. When the carbonyl group attach with an oxygen, again this bond that is attaching the carbonyl with an oxygen, we call this as ester linkage or ester bond. And the process of making a carboxylic ester using carboxylic acid and alcohol as a reactant in the presence of heat and acid, we call this process as esterification. So you remember this terminology. If I say esterification, you know we are making an ester with the help of carboxylic acid and alcohol. Okay, so let's take couple of more example and see how does the ester molecule normally form. In this particular case, we have butanoic acid and we have one alcohol called ethyl alcohol, right? So what OH from the carboxylic acid and hydrogen from the alcohol combine together and remove as water, and what else left? You left this entire you're left with this remaining structure of carboxylic acid and OCH2CH3 from alcohol. They're gonna combine together and you will get this entire molecule, right? And then where you have an ester functional group, this is your an ester functional group, C double bond O, right? So the time you see this functional group, we know this is an ester compound. We're going to learn how to name this an ester compound later on, but just right now make sure you know how to make a product if you react alcohol with a carboxylic acid. Let's take a second example over here. This is a benzene with a carboxylic acid and alcohol, and then if it react with one more alcohol called methyl alcohol, what's going to happen? OH and H reacted together and remove as water, and then what else left? This C double bond O goes with OCH3, and then you're gonna make an ester group, right? So this is how you normally do an esterification. That means formation of an ester with the help of alcohol and carboxylic acid. So you always remove water and add rest of the molecule together. Okay, so let's try to do some more example on esterification. The first one is CH3, CH2, CH2, C double bond O, OH plus OH, CH2, CH3. So in the presence of acid and heat, what should be the product? Let's do the second one. CH3, CH2, CH2, C double bond O, OH plus this is a benzene ring, and let's do the third one. Plus presence of an acid and heat, and the presence of an acid and heat. So let's try to solve these three reaction of an esterification reaction. So let's try to do the first one. So the time I see we have carboxylic acid, we have alcohol, we know this is an esterification reaction in the presence of acid and heat. So the OH from the carboxylic acid and H from the alcohol, they're gonna come as water plus water, and then you're gonna get the product CH3, CH2, CH2, C double bond O, and then O, CH2, CH3, right? And then this is your an ester group. So let's try to do a second one. So this is one of the products. Let's try to solve the second one. Again same, OH remove as water with an hydrogen from the alcohol, and then you're gonna get the product CH3, CH2, CH2, C double bond O. This is the benzene ring. and then you will have water at the end. Let's do our last example, third one. Then OH, and it's gonna remove as water. CS2 CS3. So this is the product. So you will get three different products for three different reaction of esterification. So make sure you know how to make a product if you are provided with an carboxylic acid and alcohol. So we're gonna see how to name them in later part of this chapter. But just right now, just focusing on how you're gonna make a product from the reaction given. Okay, till now we were just focusing on preparing the ester compound from carboxylic acid and alcoholic molecule. But because if you remember, we have seen all the chemical reaction on an esterification reaction where you have back and forth arrow during the reaction. So this reaction we call as reversible or equilibrium reaction. That means whatever the product, let's say if you mix A and B and you're gonna get C, that means the time you're getting C, after some time you will get an equilibrium enough, and then once you reach the equilibrium, you won't get any more C produced during the reaction, because if you're getting more C, they're gonna convert back into A and B, right? So you won't get any. So if you're using this reaction for an esterification reaction, that is carboxylic acid react with alcohol, then what you are getting right now an ester compound, right? That's what we learned from the previous slide. But because of the reaction is reversible, we are not getting enough amount of product, which is an ester. So that's why this is not the perfect way to make an ester, because you're not getting enough amount from each reaction. So we have to use some alternate pathway to make a high amount of an ester from the chemical reaction. So we are going to use two compounds that are more reactive than carboxylic acid and that produce an ester in good yield. So there are two compounds that we're going to use. One is called acid chloride. So instead of carboxylic acid, which is C double bond OH, this is carboxylic acid, right? So instead of using a carboxylic acid in a reaction to make an ester, we are going to use a substitute of carboxylic acid. That means an acid chloride. So if you see the difference between acid chloride and the carboxylic acid, what's the difference? The OH group of the carboxylic acid is get replaced with Cl. That's what the name is acid from the carboxylic acid chloride, because you have now chlorine in here. So acid chloride. So this is one of the compound that we're going to use to make a good amount of an ester compound. And if you can see, you have just one single arrow. That means you are just making more and more product. It's not a reversible reaction. Second compound that we're going to use is carboxylic acid anhydride. So if you can see what is anhydride, this is the structure of anhydride group. C double bond O, C double bond O, right? So if you can see it, if you compare with the carboxylic acid, this structure with the carboxylic acid, I can say I can remove this H from the carboxylic acid and put one more carbonyl group instead of H. So that's why this is your anhydride, right? So we are going to use these two compounds, acid chloride and acid anhydride, to make more carboxylic ester or more amount of an ester. So we'll see how does this reaction work. So the reaction mechanism will be the same. chlorine instead of OH. Right now we have chlorine, so chlorine react with hydrogen from the alcohol, exactly the same reaction mechanism that we just learned with carboxylic acid, wherein carboxylic acid OH is getting reactive with hydrogen from the alcohol, but in this particular case chlorine is going to react with hydrogen of the alcohol, so make it an acid, hydrochloric acid. Right, and then the rest of the molecule of acid part and alcoholic part is going to attach the same way it has been attaching for all the chemical reaction that we did with carboxylic acid. And then this is your an ester compound again. Right, the second reaction that we're gonna see for using anhydride, acid anhydride in the reaction, we're gonna see how does this reaction work. So you have an alcohol, so this is, which kind of bond is this one or this one? These are ester bond, ester link. Right, so what we're going to do over here, we either break this bond, and from alcohol part this OR of the alcohol is going to react with this carbon, and the H part, this H part is going to attach with this oxygen to make an carboxylic acid. Right, so you will see RC double bond O, RC double bond O, and then you have this OR group, OR dash. Whereas in the second part and the second product, this is the part RC double bond O negative, RCO O negative, and this hydrogen from the alcohol is this one. So you're gonna make a carboxylic acid with an ester. So remember the difference between these two reactions with the carboxylic acid reaction with alcohol. Right, in carboxylic acid alcohol reaction, you were making two products. One is an ester, another one is water, H2O. Whereas in these two reactions with acid chloride first, you are again making an ester, but you are making a second product as an acid, hydrochloric acid. Whereas in with acid anhydride, you are again making two products. One is an ester again, but the second product is carboxylic acid. So this is the difference between the side product that you are making, depending on which reactant you are using, whether it's carboxylic acid, acid chloride, or carboxylic acid anhydride. So make sure you know the difference. So let's take a couple of more examples on these two reactions that we just learned. This is acid chloride. Chlorine from the acid part, alcoholic part will provide hydrogen. You're gonna make HCl, and then the rest of the part get attached with themselves. So you will get CH3CO, which is this CH3CO, and then OCH2 CH3, which is this OCH2 CH3. They're gonna get attached with themselves, and then we're gonna make an ester. This is an ester, C double bond O. So this is, let's try it with the second one, which is anhydride. And I told you anhydride is C double bond O, single bond O, single bond, double bond O's. That means you have two carbonyl group and then you have oxygen in between them. So again the same reaction. This is alcohol, which is phenol. So what's gonna happen? So this bond is gonna break. Right, in this case, and then the hydrogen part will go to the oxygen of the bond, and then the rest of the part, which is oxygen included with an oxygen, is gonna attach with this carbon. Right, so you will see CH3CO with O attached with this carbon, O attached with this carbon over here, and then you have the benzene ring. And then the hydrogen is this hydrogen from the phenol, right, which goes with this entire thing. So you're gonna make an acid, carboxylic acid, and then you're gonna make an ester. Why? Because this is an ester group, C double bond O. Right? So this is how you normally make an ester using these two compounds, chloride as well as anhydride. So make sure you know this two mechanism too. Okay, so let's try to solve the couple of reaction which is given for ester formation. So the first reaction that is given is with carboxylic acid with an alcohol. So this is a simple reaction. So what's going to happen, this OH is going to react with this hydrogen and remove as water. And what else is left? CH3, C double bond O, and then this oxygen and OCH3 is going to form an ester. This is an ester. So this is a product that I just made with water. So let's try to solve one more problem. In this case we are using what? Anhydride molecule, right? Acid anhydride react with what? Alcohol. This is alcohol. So what's going to happen again? The bond is going to break, right? This CH3CO with an oxygen is going to attack this carbon, and the hydrogen, the leftover hydrogen, is going to bind with this oxygen, right? And that's how you're gonna make CH3 C double bond O, CH3 C double bond O, then this CH3CH2O, CH3CH2O, and this is your N-ester group. And then the rest over is what? You have this entire thing left, which is CH3CH2, CH3, CH2, then C double bond O, then you have oxygen, which is this, and then this is the hydrogen that is attached with the molecule. So this is an acid. So which acid is this one? 1, 2, 3, propanoic acid, right? And then we're gonna learn how to name an ester compound later on, how to name it. We're gonna learn. Okay, so now let's try to know how we can, or learn how we can name an ester compound, an ester bond containing organic compound, right? So the most important thing over here, like I told you, an ester is RCO double bond OR. And if you remember, this part of an ester compound comes from what? Carboxylic acid, right? How would you know this part is come from the carboxylic acid? Because we have carbonyl group, and then I know that acid is this COOH. This is an acid, so this part should come from carboxylic acid part, right? And then this OR part comes from alcoholic part, right? That's how you make an ester bond over here. So in an ester compound you have a mixture of compound. Once one molecule comes from carboxylic acid, another molecule or another group comes from alcoholic part. So we have to use this information to try to name an ester compound. So always make sure whenever you name an ester compound, you always name the alkyl group the R group that comes from alcoholic part first, right? So you always write alcoholic part first plus acid part, and then the ending word should always be ATE. So this is how you name an ester compound. So alcoholic part plus acid part plus an 8, right? So we're gonna do some example, and then the alcoholic part ending should be end with YL, right? So this alcoholic part always act as a substituent in an ester compound, right? So we'll see how we can use this information that I just provided to you and try to name couple of names of ester name in the next slide. Okay, so these are a couple of examples, and let's see how does it work, how to name the IUPAC name. So we know this part comes from alcohol, if you remember, and then this part comes from acid, right? So how we normally name them, like I told you on the previous slide, the alcoholic part name should use as a substituent, and then how many carbon you have in here? 1, so that's why it's methyl. This act as a substituent, and then this acid part we treat as a parent chain. So the name will be, so we are not focusing on this because these are the common name, we are just focusing on the IUPAC name, right, which is this IUPAC name, yes, right? This is also IUPAC name, right? So let's see how we're going to make an IUPAC name. So we know this is methyl, this is alcoholic part, write the substituent first, alcoholic part plus acid part. How many carbon you have in acid? 1, 2. So you have 2 carbon in the acid part and 2 carbon is ethanoic acid. So we write ethano, but because this is an ester, the ending word should end with ATE. So ethanoate. So methyl ethanoate, right? Let's take one more example. This part comes from an acid and this part comes from alcohol, right? So we know the part that comes from alcohol we use as a substituent and then we name as alkyl group, but this is a benzene ring. So remember this thing, if benzene act as a substituent onto the main chain, we don't write benzene, we write phenyl, because in this particular case this benzene ring act as a substituent on the parent chain. So if the benzene ring is act as a substituent, we use a term phenyl, right? So the term is phenyl, and then how many carbon you have in the parent chain? 1, 2, 3, 4. 4 is butane, so the term is IUPAC name is phenyl butanoate, not butanoic acid, is butanoate because ending word is ATE. Let's do the third one over here. This entire part comes from an acid, this part comes from alcohol, so this part acts as a substituent, that's why it's ethyl, you have 2 carbon, ethyl, and this part comes as an acid. If you remember, this is again benzene and we are writing benzoate. Why? Because in this case benzene act as a parent chain, not the substituent, so that's why we are using benzene, right? So this is an ester compound. Instead of writing benzoic acid, we are going to remove ic acid from here and then write AT, so benzoate, right? So make sure you practice naming of an ester. Let's take some more example. This comes from an acid, this comes from alcohol, so methyl 1, 2 ethanoate. You have ethane group as your parent chain, right? Let's take this example. This is an ester compound. This comes from alcohol. So this is 2 carbon, this is ethyl, and this acid is benzene, benzoic acid. This is an acid, so that's why it's ethyl benzoate, because this is our parent chain. Acid part is our parent chain, and this alcoholic part is our substituent. Now let's talk about the hydrolysis of an ester. The hydrolysis is the breaking of the ester bond with the help of water. So in this particular reaction, we're going to break an ester bond with the help of water. Let's take how does it work. So this is any random ester, right? C double bond OO. This is an ester bond compound, and this bond is your ester bond. So in this hydrolysis reaction, this bond is going to break with the help of water, right? And then because we are breaking this bond, this is a reverse of esterification reaction. What does it mean? In esterification reaction, we are making a bond with the help of carboxylic acid and alcohol. But in hydrolysis, we are going to break this bond. And so let's see how does this reaction goes. So in this particular reaction, this bond is going to break, right? And then from water, HOH, which is water, the OH part goes to the carbonyl group and H part will go to the oxygen. So which product you're gonna make? You're gonna make, this is the OH part that goes with the carbonyl group of the acid part, and the H goes to the alcoholic part, O negative. So you're gonna make carboxylic acid and alcohol or phenol, depending on which this R group is, whether this is CS3, CS2, or whether this is a benzene ring, right? So it may be phenol, or it can be any alcohol, right? So this type of ester hydrolysis is important in our biological system too, because enzyme catalyzed hydrolysis of the ester, if you remember, I told you at the beginning of the chapter, this ester compound is found in lipids, which is found in our body, fat, oil, and vegetable oil is an important process. So that's why this ester hydrolysis is very important enzyme catalyzed reaction. Okay. Let's take a couple of more examples on ester hydrolysis. So this is one of the ester. What the name? This is a common name, so we are not going to use a common name. We are going to use a IUPAC name. So what should be the name for this ester? So this is part comes from alcohol. This part comes from acid, which is a parent chain. So I can write the name of this ester is ethyl, because you have 2 carbon, and you have 2 carbon in your parent chain too. Ethyl ethanoic acid, but this is an ester. We are going to write ethanoate, OAT, right? Because this is an acid part. So if it react with water, what's going to happen? This OH is going to attach with the carbonyl group, and the hydrogen is going with an oxygen. So you're gonna make an acid. This is a common name, but we're going to write the IUPAC name, which is ethanoic acid, because this is an acid, COH. And you're going to make an alcohol too, so this is ethyl alcohol, or this is a common name, we can write ethanol. So let's take one more example. You have water, you have an ester compound, that means this is an ester. So what you're going to do, this bond is going to break. Water, I can write HOH. OH part is going to go with carbonyl group, hydrogen part is going to go with oxygen. Then you're gonna make benzene plus OH group, carboxylic acid group, with an alcohol. So this is benzoic acid. Benzoic acid, because this is benzene, this is carboxylic acid, benzoic acid, and this is ethanol again. But this is 1,2-ethane and this is alcohol, ethanol. So this is how you normally perform an ester hydrolysis. And then I already told you in ester hydrolysis you're gonna break the N ester bond and then convert an ester into a respective product, which is basically an acid and alcohol, because this is the way you normally prepare an ester compound, right? So this is the reverse of esterification. So you have to know this difference. So our last topic is saponification. Saponification is the basic cleavage of ester linkage. Whenever you have to break an ester linkage or an ester bond in the presence of a base, we call this reaction as saponification reaction. And then whenever you do this saponification reaction, you will get an alcohol and carboxylic acid. Because if you're breaking an ester compound, an ester bond, then the product will be always be an alcohol and carboxylic acid. Right? And it carried out with a strong base to produce carboxylic acid. So how the reaction is going to go? Let's see the reaction. This is an ester. We know this is an ester compound or ester bond. This bond is going to break, and then in this particular case we are not going into a mechanism how does the reaction mechanism works in this particular reaction, but you have to just know then in this particular reaction sodium hydroxide NaO, in this case sodium and oxygen is going to go with this carbonyl group, and the rest of the hydrogen which is left behind is go with oxygen. So what you're going to make? You're going to make RCO, which is this, and then ONA, which is this ONA. So what you're going to make? You're going to make a salt, and then the other one is RO, and then this is H, an alcohol. So that means whenever you do an saponification reaction on an acid and you break a ester bond, you always is going to make a salt with an alcohol, right? Which is different than water hydrolysis or hydrolysis reaction, where you normally form carboxylic acid and alcohol, but in saponification you're gonna make an salt, not an acid as a product. So this is the difference between saponification and hydrolysis of an ester compound. So make sure you know this difference. Let's take one example of saponification reaction and then try to apply the concept that we learned in the previous slide. So this is an ester compound. We know this is a bond. So what's going to happen? This bond is going to break. This is an ester bond, right? And then I told you in the presence of a strong base in the process of saponification, NaO is going to attach with carbonyl group, and then the hydrogen is going to go with an oxygen, and this bond is going to break. So your product will be ONA with carbonyl group and then CH3OH, which is this, right? This is the H. So you're gonna make a salt. And what's the name of the salt? If you remember from the previous slide that we learned how to name a salt, which is metalline sodium, and then the salt is always end with ATE again. So instead of writing benzoic acid, you're gonna write benzoate, because this is a salt, and then you're gonna get an alcohol. So again you're getting salt and alcohol in saponification reaction. So make sure you practice on hydrolysis as well as on saponification reaction. So I think that will be it for this particular lecture.